Hello everyone. In this video, let's do some case study questions from the chapter Polynomials. I have selected 3 case studies from sample papers uploaded in the CBSE website. First case study. If the roller coaster is represented by the following graph y equal to p of x, then name the type of the polynomial it traces. Options are linear, quadratic, cubic, biquadratic. Here we see that the graph intersects the x-axis at 3 distinct points. This is one point of intersection, another point of intersection, and third point of intersection. So the degree of the polynomial will be 3. Hence, the polynomial will be a cubic polynomial. The roller coasters are represented by the following graphs y equal to p of x. Which roller coaster has more than 3 distinct zeros? Again, we need to see at how many points the graph cuts the x-axis. In option A, the graph intersects with the x-axis at only one point. In option B, again the graph intersects at x-axis only at one point. In option C, the graph intersects the x-axis at 3 different points. And here in option D, the graph intersects with x-axis at 1, 2, 3 and 4 distinct points. So for this graph, the degree is 4 and it will have 4 zeros. The question is which has more than 3 distinct zeros? So the option will be option D. If the roller coaster is represented by the cubic polynomial t of x equal to px cube plus qx square plus rx plus s, then which of the following is always true? So for p of x to be a cubic polynomial, this expression, this term px cube should be not equal to 0. So the coefficient of the x cube term, that is p, should not be equal to 0. So the correct answer is option D. If p is 0, then the entire term will vanish and we will have only qx square plus rx plus s. So it will be just a quadratic polynomial and not a cubic polynomial. If the path traced by the roller coaster is represented by the above graph y equal to p of x, sorry, it's below, find its zeros. So to find the zeros from a given graph, we have to check the x coordinate of the point of intersection with the x-axis. Here the x coordinate of this point is -3. For this point of intersection, the x coordinate is -1. For this point of intersection, x coordinate is 2. So the zeros are -3, -1 and 2. Option C is the correct answer. Case study 2. Annie was standing on a diving board 48 feet above the water level. She took a dive onto the pool. Her height in feet above the water level at any time t in seconds is given by the polynomial h of t such that h of t is equal to -16t square plus 8t plus k. What is the value of k? Options are 0, -48, 48, 48 by -16. Now let's first observe the image and understand the case. There is a swimming pool and the diving board is at a height of 48 feet above the water level. This height is 48. Annie dives into the pool from this diving board and the path traced by her is that of a parabola. The parabola is described by the polynomial h of t. So here When t is equal to 0, Annie is still standing on the diving board. So her height above the water level is 48. So at t equal to 0, h of t will be 48. So using this, we will try to find the value of k. Let's substitute t as 0 in h of t. H of 0 is 48. So minus 16 into 0 plus 8 into 0 plus k is equal to 48. Both the terms are 0, so k will be 48. So the constant k is 48. Option C is the correct answer. Next, at what time will she touch the water in the pool? The polynomial given was minus 16t square plus 8t plus 48. We found the value of k as 48, so we can use it here. Now, when she touches the water in the pool, that is at this instant, her height above the water level is 0. So, h of t will be 0 when she touches the pool. So, let's equate h of t to 0 and find the value of t. So, this is a quadratic equation in terms of t and we need to solve for t. Let's divide the entire equation by minus 8. So, we will have 2t square minus t minus 6 equal to 0. So let's split this minus t as minus 4t plus 3t minus 6 will remain as such equal to 0. So I've just split the middle term here, minus t into minus 4t plus 3t. 2t can be pulled out as common. You will get t minus 2 plus 3 can be pulled out as common here. So you get t minus 2 equal to 0, which gives us t minus 2 into 2t plus 3 equal to 0. T minus 2 will be 0 or 2t plus 3 will give you 0. T is 2 or t is minus 3 by 2. T is time in seconds, which cannot be a negative quantity. So t equal to 2 is the correct answer. Option B, 2 seconds. Rita's height in feet above the water level is given by another polynomial p of t with zeros minus 1 and 2. Then p of t is given by. Here the zeros of the polynomial are given and we need to frame the polynomial. Let's consider zeros to be alpha and beta. So we know that the polynomial can be expressed as a constant into t minus alpha, t minus beta. Substituting the values of alpha and beta, t plus 1, t minus 2. Simplifying, we get t square plus t minus 2t minus 2. So we have k into t square minus t minus 2. So here again, when t is 0, Rita will be still standing on the board. So p of t will be 48. So let's substitute t as 0 here in this expression and equate it to 48 to find the value of the constant. P of 0 is equal to 48. 0 minus 0 minus 2 into k is equal to 48. k minus 2k is 48, k will be minus 24. So using the constant as minus 24, we will get the expression as minus 24 into t square minus t minus 2, which is nothing but minus 24 t square plus 24 t plus 48. Option D is the correct answer. A polynomial q of t with sum of zeros as 1 and the product as minus 6 is modeling Anu's height in feet above the water at any time t, then q of t is given by. So here we need to frame the quadratic polynomial. The sum of the zeros and the product of the zeros are given. So alpha plus beta is given as 1 and alpha into beta is given as minus 6. By looking at this, we can say that alpha will be plus 3 and beta will be minus 2. So sum will be 1, 3 minus 2 and product will be 3 into minus 2, which is minus 6. So with this, we can frame the polynomial as constant k into t minus alpha into t minus beta. K is t minus 3 into t plus 2, which will give us k into t square minus t minus 6 q of t. We need to find the value of the constant k. Here again the same logic. When the time is 0, that is q of 0 will be 48, because when t is 0, the girl is standing right on the board, which is 48 feet above the water level. So let's substitute t as 0 in this expression and find the value of k. K into 0 square minus 0 minus 6 will be 48, minus 6k is 48, so k is equal to minus 8. So q of t is minus 8 into t square minus t minus 6, which is minus 8t square plus 8t plus 48. So it is option C. Next, moving on to next case study. Basketball and soccer are played with a spherical ball. Even though an athlete dribbles the ball in both sports, a basketball player uses his hands and a soccer player uses his feet. Usually, soccer is played outdoors on a large field and basketball is played indoor on a court made out of wood. The projectile path traced of soccer ball and basketball are in the form of parabola representing quadratic polynomial. So they have given the pictures as well. Here you can clearly see the ball traces a parabola shaped path. Here again the shape given is that of a parabola. Let's move on to the questions. The shape of the path traced shown is spiral, ellipse, linear, parabola. It's a parabola. The graph of parabola opens upwards if, okay, the graph of a quadratic polynomial will be open upwards when a, which is the coefficient of x square term, is greater than 0. So option C is the correct answer. The parabola will be facing downwards if a is less than 0. Observe the following graph and answer. In the above graph, how many zeros are there for the polynomial? Again, the graph cuts the x-axis at 1, 2, 3 distinct points. So there are 3 distinct zeros. Option B, 3. The 3 zeros in the above shown graph are, So the zeros are the x coordinate of the points of intersection. Here it is -3, here it is -1, and here it is 2. So the zeros will be -3, -1, and 2. Option C. That's the end of the video. Thanks for watching and hope you liked it. Please subscribe to our channel and also press the bell icon to receive notifications as and when we upload new videos. Thank you and have a nice day.